क्या है कैंडिडेट नंबर क्या है?
तो आ गया ना यार, हमारे एसओई कितनी अजीब सी है।
हमारा क्या
एसओई कितनी अजीब
स्टेटमेंट?
हाँ ना, वो है ना डायरेक्ट प्रिंट वाली है, समझो सेट की तरह एक तरह से।
चलो स्टार्ट करते हैं. स्टेट न्यूटन्स लॉ ऑफ ग्रेविटेशन. सही
फॉर्मूला
है.
लिखना है।
Yeah, so basically in words, right? So
डायरेक्टली प्रोपोर्शनल है
the gravitational force is proportional to product. Yeah.
of the masses and inversely proportional to the square of the rate, or the distance between the centers of the two masses.
So yeah, and inversely, how do you spell? Care. My spelling was never the best. Inversely related with square of the distance between their centers. And the important thing here is, ये तो सब लोग कर लेंगे, is that you either write that they are point masses, or you write, between the distance from their centers, or you be edgy like us and write both. But that's important to show that all mass is assumed to be concentrated at the center. And basically what you have to do here, अगर formula याद है gravitational force का, which was this, इसको basically आपने बस words में लिखना है. सही है. So a satellite of mass m has a circular orbit of radius r about a planet of mass m, mass capital M. It may be assumed that planet and satellite are uniform spheres that are isolated in space. तो कोई दूसरे की field नहीं है. Show that the linear speed of the satellite is given by the expression where g is the gravitational constant. So you take the force provided by gravity as centripetal force.
Yep.
So you have m on r square g. And this is mv square over r, or sorry, capital R ही लेते हैं. I mean,
the
like,
R and R cuts out.
small r ले लो
sorry, sorry, smaller ले लेते हैं. That's what's given. Basically idea is, in this case r is the same because it's just the radius of the orbit of the satellite. I'm not talking about the Earth's radius or anything like that.
square r square.
So yeah, oh yeah, sorry, r square इधर है. And then you simplify, r इधर से कट गया, इधर से ये कट गया, mass कट गया. You're left with g m over r is equals to v square, and you take square root on both sides, giving you g m over r ka whole root. So two moons A and B have circular orbits about a planet as illustrated in figure 1.1. It's not to scale. Moon A has orbit radius of something and something, period दिया हुआ है, linear speed दी हुई है. Same done with moon B. Now to determine the ratio of VA to VB, and which is basically you just input it into this formula, right? The idea, sorry. Yeah. Idea here is, for any given planet, m was the planet ka mass, right? So m would be constant, g is a constant. So basically आपका ये हो क्या रहा होगा, you'll be writing root em over va का जो भी radius है, it's 1.3 into
yeah
10 to the power 8, and you do the same thing. थोड़ा सा बड़ी handwriting हो गई. 2.2 into 10 to the power 10, and then you just simplify. सही है. root कट जाएगा, gm सही, root in fact कटेगा नहीं, whole root हो जाएगा, but gm कट जाएगा, and you just pop it into the calculator. So ta over tb, ये निकाल.
For this we'll use t square is proportional to r cube.
Sorry, hello.
T square is proportional to r cube.
T square is proportional to r, इसे explain कर दो थोड़ा सा.
एक्सप्लेन
um
ये इस्तेमाल हो जाएगा रेडियस पता है तो जो
So I think
उससे
he's
रेशियो
asking
आ
like,
जाएगा
how did you get
रेशियो
here?
इस्तेमाल करना है ना
yeah, how did you get
Proportional to r cube तुमने ये derive किया था मुझे याद है क्लास में, but like how do you get there? That's what they're asking.
do you get it through omega?
हम इसको कर तो सकते हैं इसमें कुछ चीज़ नहीं है ये तो यही GMM अपॉन वो करना तो मैं क्या कहते हैं
Do you do it like this? सही है. So v is equals to rw, omega is 2 pi over t, and r इधर जाएगा तो it
हाँ
has to
सही है
be
अच्छा हाँ.
gm over r cube.
ये असल में केपलर का थर्ड लॉ भी है ऐसे ही बोल रहा हूँ ये फैक्ट के तौर पे
अच्छा.
It's
Sorry.
okay.
Okay, and then when you flip that, you simplify this, you get t square is proportional to r cube. And बाकी सारे constants हैं, so we don't really care about them. You can just pop in r cube, and you'd get it. So you basically you get 1.3 into 10 to the power 8 carne upon 2.2 into 10 to the
Well,
power 10.
ऐसा
पावर 3/2
रेसिप्रोकल वो उल्टा नहीं था, like 2.2 ऊपर नहीं जाएगा.
I'm sorry.
GM upon R था ना, like the will flip ना.
I mean, I just what I did, I just flipped this, right? So I just flipped this upper.
हाँ ना
नहीं,
सही है ना 3/2 बस सही है 3/2 डाल दो पावर के तौर पे
Oh हाँ, sorry, because either to get t you'd, yeah, sorry, 3 upon
अच्छा ओके, सॉरी मैं VA को देखा था. हाँ, never mind.
so 3 upon 2. And like please don't, अगर मैं numerator में 3 upon 2 कर रहा हूँ, denominator में 3 upon 2 कर रहा हूँ, that is the same thing as whole fraction पे 3 upon 2. सही है. The planet spins about its own axis with angular speed of this. So this is angular speed है ना, तो omega. Moon A is always above the same point on the planet's surface. Determine the orbital period TB of Moon B. Acha, so Moon A is always above the same point on the planet's surface. So kind of like your geostationary satellite wali cheez. Is that correct? Hello? Can someone provide validation? Verification rather, but
हाँ तो
yeah. So idea is कि planet
एंगुलर स्पीड सेम होगी फिर
yeah, planet आपका ऐसे move कर रहा है, but the moon is also, if this is moon, it's also moving on the same क्या कहते हैं,
yeah if it's vertically above then it's also moving at the same angular speed
yeah, basically. So it's kind of
because it
similar,
has to complete a rotation in the same time
yeah, so kind of like your similar principle to geostationary satellites where they are also like always vertically above a single point.
it is not similar it is a moon is a satellite
Yeah, so but पता करना है आपको orbital period TB of moon B. तो moon A के लिए हमें क्या करना है? Moon A के लिए I guess you have to figure out what orbital period नहीं, ये तो can someone help a bit?
क्या है मैं the planet spins about its own axis
Huh? If you get या तो moon A के लिए आपने R निकाल लिया, is the ratio always going to be the same क्या? If that is so, then you can very easily take it out. आपने T से कर लिया.
हाँ ना सही तो है TA आ जाएगा फिर TB निकाल
Okay.
we have TA we have the ratio TA upon TB we can get TB
Yeah, so this is the omega. I'm taking off for moon A at the moment. Omega is 2 pi over T. Matlab T would be 2 pi upon omega, which is 1.7 into 10 to the power minus 4. This is the you know the time it takes for one rotation of moon A. Say or the planet, whatever you want to call it. Iska, can someone pop this? Does anyone have a calculator? Or I have a calculator. So wait, kiss moment. So 2 pi divided by 1.7. This is giving you a value of 3695 9.9. A very awkward way to write it. My apologies. And then this is basically of moon A. You know TA over TB is what? It is whatever answer was here. I didn't calculate it, so let's just pick it from the
Just
mark.
write A.
Huh?
Just write it that way. यार.
Just
Just write
the
part
answer
2
of
का आंसर
part.
मल्टीप्लाई करना है.
Oh yeah.
Right.
Okay. So yeah, and this is basically part 2 ka answer. And you basically just take TA, which you just calculated, you divide it by part 2 ka answer. You get TB.
And you have TB.
And you just input TB.
Not that TB, just this
You're
TB.
dead.
Mother, you get both. So yeah. So explain what is meant by internal energy. So sum of
Potential and kinetic.
Potential and kinetic energies of gas particles or of a gas or of whatever. Iski, I just want to check the marking scheme to ensure we got the wording correct. Sum of kinetic and potential energy of atoms, molecules, reference to random distribution. So sum of random potential, is that fine? Hello?
I guess.
Ali, Imad.
Please provide.
हाँ.
Imad is dead. Okay.
Imad नहीं है.
Imad nahi hai, sad life.
हाँ क्या हुआ?
Internal energy ka, does this look fine to you?
हम और क्या करें?
Say okay. But can you briefly explain why we add random?
Random? Random क्यों है?
Marking scheme है सारे.
नहीं तो वैसे भी याद तो है कि reference to random distribution, how it's there कोई uniform.
अच्छा यही है कि ये लिखा हुआ है कि that potential and kinetic energy is randomly distributed among the particles.
Yeah. So you just need to flaunt your knowledge about that. So yeah, the basic assumption of the kinetic theory of gases that leads to the conclusion that there is zero potential energy between the molecules of an ideal gas. Reason being potential energy is state karna hai. The basic assumption. So we have to just state the basic assumption of the kinetic theory of gases. And since potential energy depends on, either the part space between the molecules or the intermolecular forces, the assumption that we make in kinetic theory of gases is that in an ideal gas there are no intermolecular forces. So the gas particles don't attract each other, van der Waals, no stuff like that. So the pressure P and volume V of an ideal gas are related by this. You have stuff. Use this equation to show that the mean kinetic energy EK of a molecule is given by 3/2 kT, where K is the Boltzmann constant and T is the thermodynamic temperature. So yeah, so just correct me if I start going wrong.
You just want half MC square at one side and बाकी वही side will take care of it.
Yeah, so EK is basically your half
MV.
MV square.
C square लिख दो.
Sorry, C square जो भी आपके है इधर. PV को हमें if you remember, PV is equals to nRT जो हम पढ़ते थे. So I can add nRT here, and the reason I'm doing so because I know I want temperature, right? So like even if I don't remember the derivation, it intuitively makes sense. This is number of moles, number of molecules, mass of a molecule. Can I write Nm as a large M? Or does I have to go there?
You want small m. Essence, you want it for one molecule, not for all molecules.
Yeah, it will be small.
Yeah, my bad.
N divide हो जाएगा नीचे जाके वो
So
बन
you
जाएगा.
get, and you get N
After
here.
that,
So yeah, and you have MC square. All you know now, as you know, we need half MC, मतलब वो जो mean square जो भी है. So we'll divide both sides by 2 to get that. So that इसको तो आप at least EK लिख सकते हो, mean EK, right? On average. So you just need to simplify this out. And if you look at it, so 3 upon 2 to aa gaya, you have 3 upon 2, so you just put that on the side.
NR upon N is K. That's a fact.
Yeah. The idea here is,
rather show that in 2 steps to be safe.
so N is number of moles. Say that is small n. Capital N is how much?
Number of particles.
Number of molecules. Say so if you look at number of moles basically is
Number of moles upon number of particles gives the Avogadro constant.
Yeah, acha, okay.
Gives the inverse of the Avogadro constant.
Yeah. So I'm just trying to simply write it either कि number of moles is equals to number of particles, that is n. So I'm saying number of moles small n is equals to number of particles, that is n into 6.0.
Divide by n a लिख दो.
Divide by a लिख दो.
Yeah, your Avogadro's constant, and you take this here, say giving you 1 over a. And if you have r upon your Avogadro's जो भी av लिख दो into t, r upon r is a constant 8.31. Avogadro's number is also a constant. So you're left with, you can write this as constant k, which वैसे you should know is the Boltzmann constant, and you're good with this. Can someone try to explain this in a little better manner? I don't think I managed to fully communicate.
It's just your number of moles का formula है ना कि number of moles is number of particles upon Avogadro's constant, and then you just like take number of molecules side per 2.
The Avogadro's constant is the number of particles per mole.
हाँ ये भी है.
That's the day. So if we were to say the number of moles per particles, that it would be the inverse of the Avogadro's constant. And R upon A is K. Another way to look at K is that instead R is the way R is for the number of moles, the same way K is for the number of particles.
Okay. So hopefully that's good. And we have 4 minutes to finish this. Okay. So a cylinder contains 17 grams of, okay, yucky color, but of oxygen gas at temperature 12 degrees Celsius. The mass of 1 mole of oxygen gas is 32. It may be assumed that oxygen behaves as an ideal gas. Calculate for the oxygen gas in the cylinder the mean kinetic energy of the molecule, which is just using this formula. So you would put 3 over 2. K is a constant that you can pick from the starting of the booklet. I'll just इधर कहीं होता है, किधर होता है K? Yeah, the Boltzmann constant. So you can just pick, paper में दिया होगा, टेंशन की बात नहीं है. Temperature is in Kelvin, correct? So you basically add 273 plus 12 to convert it into Kelvin, and you multiply and you get the mean kinetic energy of a molecule. You want the number of molecules. So so number of molecules, mole निकाल लो, easy होगा. 1 mole ये दिया हुआ है, say 1 mole, and it's kind of, वैसे अगर physics chemistry याद है तो it should be obvious as well. 1 mole is 32 grams. X mole is 17 grams because that's what we're given. So it's 17 upon 32. Those are the, the number of moles you have, 0.53125, but let's just try 0.53. If 1 mole has 6.02 into 10 to the power 23 molecules, then 0.53 moles would have 0.53 into 6.02 into 10 to the power 23 molecules. So you just multiply and you get your answer, which is somewhere around 3.2 into 10 to the power 23. Now they want the total internal energy, and here's what you have to here's something that you have to use from the previous part जो हमने इधर लिखा था कि the idea here is that there is zero potential energy in an ideal gas because there are no intermolecular forces. So internal energy, instead of depending on potential energy and kinetic energy, since there is no potential energy in an ideal gas, only depends on kinetic energy. So it basically you just have to calculate the total kinetic energy. This was the kinetic energy of of a molecule. You have the number of molecules, you multiply, you get the total kinetic energy. So you just part 2 ko lo into part 1 kar lo, you get total kinetic energy which is equal to total internal energy. Sahi hai? Did I explain it correctly? Can someone give me some validation?
हाँ सही चलो आगे.
Chalo, let's continue the question 3 from the next video.